Okay, so today we can look at the total surface area of triangular prisms. So now we shall use a simpler method, and then at the end of the video we shall talk about why this method is working. So first of all, let's start with this one here. So find the total surface area of the following triangular prism. By all means, it's okay. You can find the area of this face, the area of this face, the area of this face, the area of that face, and the area of that face, and then add them all up together. You still get the same correct answer, except that that may take some time. So now let me just show you an easier way of finding the total surface area of this. So the total surface area, or TSA, is given by, you find the area of the two triangular faces first. So because we have two triangular faces, instead of saying half BH plus half BH, we can just add these two together, because we know that half plus half is a 1. Like half an orange plus half an orange, you have 1 orange. Or you can just find the common denominator, and then you realize that at the end of the day you have 2 over 2, and then 2 over 2 is just the same as 1 BH. So to find the total surface area of the two triangular faces, all you need to do is multiply the two perpendicular sides. Now, how do I know which two sides are perpendicular? Well, this is easy. Two sides are perpendicular when they are meeting at a right angle. So in case you are doubting, you can always look for this small square. The small square will always tell you which two sides are perpendicular. So if this is perpendicular to this, we normally put a small square like this. Then in a case like this, if these two are perpendicular to each other, then we put a small square like this. And this will be your B, this one will be your H. In this case, this will be your B, and then this one will be your H. By the way, I'm talking about this entire part here. So in this case, we have this, which is perpendicular to this because of this square here. We're not going to multiply this by this, or this by this, or this by that. We are multiplying two sides which are perpendicular to each other. So we have a 12 centimeters, which is perpendicular to 8 centimeters. And then next, we shall find the area of this face, and the area of this face, and the area of the other face on the other side. So now, as you can see, to find the area of the bottom part, you have to multiply 20 by 12. And then to find the area of this face, you have to multiply 20 by 8. Then to find the area of the face behind there, you multiply 20 by this side here, which is 10, because this is the same as this, which is the same as that and that. So now, since we are using 20 3 times, we can just write it like this. I'll explain why at the end, but technically speaking, I've just factored the 20 out. Or maybe let me do this. So we say 12 times 8 plus 20 multiplied by 12 plus 20 multiplied by 8 plus 20 multiplied by not 8, 10, and then 20 multiplied by another 10. Since this is 10, just like this, and this one is also 10. So now when you factor the 20 out here, you have something like 12 multiplied by 8 plus 20. So when I factor out a 20 here, I'll remain with a 12. When I factor out a 20 here, I'll remain with a 10. When I factor out a 20 here, I'll remain with another 10. So in short, what you do to find the total surface area of a triangular prism is you just multiply the two triangular faces, the two perpendicular sides of the triangular face. And then once you do that, get the height of the triangular prism. So the height of the triangular prism is the distance between the two triangular faces. You have this triangular face and this triangular face, and then the distance between them is the height of the triangular prism. So that's a 20. And then after that, you add the 3 sides, or the 3 dimensions forming the triangular face. So we have a 12, a 10, and a 10. A 12, a 10, and a 10. So now let's simplify this to find the total surface area. This is true in general, by the way. So we have 12 multiplied by 8. Let's multiply this together. This times this is 16, carry 1. This times this is 9 plus that, 8 plus that, we have a 9. So this is 96 plus 20 multiplied by 10 plus 10 is 20 times this is 32. So now you can say 96 plus, we have a 0, so you can just write it at the end and multiply 2 by 36, which 2 times 2 will be 4, 2 times 3, we have a 6. So this is like 640. Then now when we add these two numbers together, you can say 0 plus 6, so 6 plus 0, that's 6. Then 9 plus 4, that's 3, carry 1. And then 6 plus 1, we have 736 square centimeters. Because we have centimeters there, we have centimeters here. And then because we are multiplying 2 dimensions for each, we have a square there. Let's move on to the second one and quickly use the same idea as before. So now to find the total surface area of this, you can say area is equal to, in this case, the perpendicular sides are this and this. It doesn't matter how this thing has been positioned or drawn, whether it's upside down, it's upright, or in whatever manner they've decided to make it, just look for the two perpendicular sides. So in this case, we have this one, which is perpendicular to this. So you can say 16 multiplied by 6, and then plus the height of the triangular prism. Remember, the height of the triangular prism is the distance between the two triangular faces. So we have this triangular face and this triangular face. So the distance between these two triangular faces is 22. So you write this one and then open the brackets like this. And then at this point, you get the 3 dimensions or the 3 sides forming the triangle. So our triangle here is this. This is our triangle. So we can say we have this side 16 plus this side. Remember, this is the same as this. So if this is a 10, then this is also a 10. And then plus, if this is a 10, this is also a 10, and this is also a 10, since these are all the same. Which is why we have these two lines there. The two lines are telling us that this is the same as this, which is the same as this, which is the same as this. And then the single line is telling you that this is the same as this, which is the same as this. So now you don't need to add this 6 here. You only use the 6 when finding the areas of the two triangular faces like this. You don't need it here because this is not part of the 3 sides forming the triangular face. So now let's simplify. According to BODMAS, we can start with the brackets, but since this is independent of the brackets, we can also multiply these. So you can say 16 multiplied by 6, this is 96. This times this is 36. Then this times this is 6. 6 plus 3, we have a 9. So this is 96 plus 22. And then let's add the numbers in the brackets. If you want, you can start with expansion, but it's much easier when you start with addition. So this plus this is 20, plus this we have 36. And then now we have 96 plus 22. Okay, let's just multiply 22 by 36. So 2 times 6, we have a 12, carry 1. This times this, 3 times 2 is 6, plus that, we have a 7. Since we still have the same numbers, we can proudly say 76. Of course, we need 72. And of course, we need the placeholder there. Then 2 plus 0 is 2. 2 plus 7 is 9. then 7 plus nothing, we have a 7. So this is 792. So now the total surface area here will simply be the sum of this and this. So now let's add 96 to 792. 2 plus 6, we have an 8. Then 9 plus 9, we have an 18. Carry 1. Then 7 plus 1, we have an 8. So this is 888 square centimeters, and you are done. So now part C. On part C, we have something that is a bit different. This is from 2022, paper 2. So in this case, according to their drawing, it's quite tempting to think that the perpendicular sides are these two. But regardless of how the drawing looks like, your roadmap, or maybe your guide must be this small square there. This is what you always want to look for. You don't have to look, or maybe just use your protractor to measure an angle somewhere. No, just look for the small square and you'll be in the right path. So to find the total surface area of this thing here, you can say area is equal to, remember what we said, BH, you multiply the two perpendicular sides of the triangular face. So in this case, we have 3, which is perpendicular to 4. I know it looks like 5 is perpendicular to 3, but it's not. As long as you can't see the square, the small square there, just know that this is something else. It's not really perpendicular to that. So you can say 4 multiplied by 3, and then you say plus the height of the triangular prism. So the height of the triangular prism, once again, is simply the distance between the two triangular faces. We have this triangular face and this triangular face. So the height will be the distance between these two faces, which is a 12. Then in the brackets, add the 3 sides or 3 dimensions forming the triangular face. So this triangular face here has 4, 5, and 3. Sometimes one of the numbers may be this side, but this is always the same as this. So if you have a 5 here, just know that this one is also a 5. So you can say 4, this one, plus 5, plus 3. And then we can manipulate. So 4 times 3 is 12, plus we have a 12, and then let's add the numbers in the brackets. As usual, if you want, you can expand and add the products, or you can add and multiply the sum by this. It's all the same, except that multiplication is much harder. So 4 plus 5 is 9. 9 plus 3 is 12. So we can say 12 times 12. And then this is a very famous product. 12 times 12 is equal to 144. And then your total surface area will therefore be 144 plus 12. This plus this is 6, this plus this is 5, and then you have a 1 there. So this is 156 square centimeters, and you are done. So it's this easy. And then lastly, we have this one here. So on this one, we have a similar case as in part C. So despite the way this thing has been aligned, you still have to find the small square in order for you to know which two numbers to multiply to find the area of the two triangular faces. So we have this triangular face, and as you can see, we have the small square here. Another one is there. This is just the same as that. So these two sides here are perpendicular to each other because they are forming this right angle there. So you can say 8 multiplied by 6, this 8 and this 6, and then plus, you get the height of the triangular prism. So in this case, we have the triangular face here and then another triangular face here. So the height of the triangular prism is the distance between the two triangular faces. So in this case, that's 10 centimeters. So you can say 10 centimeters. And then in the brackets, you get the three sides forming the triangle, the three dimensions of the triangular face. So you have an 8 plus, you have a 6 there, plus we have nothing there. But of course, we know that this is the same as that. So if this is a 10, then this one is also a 10. So you can put your 10 centimeters there. So that you have 8 times 6, which is 48, plus 10. And then 8 plus 6, this is 14, plus 10, this is 24. And then our area will be 48 plus this times this one will be 240. And then from here, we can simply add these two, 240 plus 48. So 0 plus 8 is 8. 4 plus 4 is 8. Then 2 plus nothing, we have a 2. That means our total surface area here is 288 centimeters squared. So it may not always be square centimeters. Just make sure that you check whatever has been given. If you have meters there, use meters. If you have centimeters, use centimeters. You have kilometers, use kilometers, and then include your square. So now, at this point, the tutorial is over. But if you want to understand the formula, we can talk about it now. And then this is the work I'm expecting you to do. So calculate the total surface area of the following triangular prisms. So you can just pause the video and copy the questions down, or at least work them out. So this is these are the last two. This is 6.4 centimeters. This is 4 centimeters, 10, 15. This is 10. This is 6. This is 8. This is 12. And this is 8, 15, 17, 20. Then 12 centimeters, 15 centimeters, 9 centimeters, 20 centimeters. 8, 12, 5, 3 for the perpendicular height, and then 8, 12, 10, and 30 centimeters. So now I want to use the last part to explain why this formula is working. Like I said earlier, if you have this triangular face like this, and then this one is your small letter h, which is the height of the triangular prism. Then this is like your base. Let's call this one A and B. And then this one here will be capital letter H, because this is the height of the triangular prism. So if this is A, this is also A, this will be B, then this one will be C. Then we also have another H there. So to find the total surface area of this, you can start by finding the area of this. So this is just the explanation of how the formula came about. This is optional. You can skip this part if it's too complicated for you. So you can say half BH. So to find the area of this, you say half multiplied by base times height, where B is perpendicular to H, plus we also have another triangular face there. So you can say half BH. And then plus we have this face here. So for this face, you can say capital letter H, which is the height of the triangular prism, multiplied by B, and then plus we can find the area of the bottom part, which is capital letter H times B. Actually, this is supposed to be a C. So multiplied by C, this time C. Then our B is here, then plus. Remember, if this is H, then this is also H. So to find the area of the other face on the other side of the line, then you can say h times a, h multiplied by a. So that means the area here will be, let's add these two. The common denominator here, this is like bh over 2 plus bh over 2. So the common denominator here is 2. Then 2 into 2 is 1 times this, you have bh, plus 2 into 2 is 1 times that, you have another bh. Then bh plus bh, we have 2bh over 2. And then this and this into this is 1, so you have a bh. So this plus this will give us bh. And then plus, we have capital letter H here, capital letter H there, and capital letter H there. So you can just factor it out and say H. When you factor an H out from here, you remain with a C. From here, you remain with a B. From there, you remain with an A. And then rearranging the numbers, or maybe the letters, you have A plus B plus C. So the area of the triangular face or the triangular prism is given by B times H multiplied by capital letter H, which is the height of the triangular prism. And then in the brackets, you have A plus B plus C, which are the 3 dimensions forming the triangular face. Okay, we can end here.